Hi, my name is Josh Garrick, and today we're going to be going through some of the practice problems that were passed out in class for our Chem 1310 Test 1. So we're gonna. I wrote up a couple of the questions and how I worked through them. It's just 5 right now, but it really is like a summary of probably what's going to be on the test that's coming up in a second. So here we go, starting with I guess number 1. So here we have, as it says, when the equation NH3 plus O2 produces NO and H2O is balanced with the smallest set of integers, the sum of the coefficients is. So pretty much this question is just asking you to really correctly balance the equation that was unbalanced before and add up the single integer coefficients to get the right answer. So the first time I wrote it out, I just started with nitrogens and balanced them out. So we had 2 and then 2 on the we had 2 and then 2 on the other side, and then to balance that out with the oxygens we'd have 3 here, and that would cause it to be 5 halves. So if you multiply everything by 2, you'll get 4, 5, 4, and 6. Add that all together and you get 19, and that's answer choice D, so that's the right answer. Okay, moving on to question 2. Which of the following has the greatest percentage of nitrogen by mass? So pretty much in this one, you just want to take your mass of nitrogen being 14.01, and you want to divide that by the mass of the whole compound. So with NH3, it's going to be 14.01 divided by 17.01. Well, you can see the different operations we did for each one: NH3, NO3, N2O, C6H4, N3O6, and HCN. And we got our percentages by mass. We got all of them for each compound. And our greatest percent by mass was going to be in NH3 at 82.36%. So again, that was just dividing the mass of nitrogen by the mass of the whole compound and multiplying that by 100 to get the percent. And our greatest was A in NH3, so that's the right answer. Okay, going on to number 3. We have the question stating, vitamin C contains the elements carbon, hydrogen, and oxygen, and contains 40.9% carbon and 4.58% hydrogen by mass. The molar mass of vitamin C has been found to be about 180 grams per mole, and the molecular formula for vitamin C is what? So that's what the question is asking. So with the molar mass of 180, we can, well, pretty much we know 40.9% and 4.58%. We add those together and subtract that from 100 to find the percent of oxygen in the compound. And then we take those and put them as decimals instead of percents and divide that by the mass of each of these elements by itself. So we do those 3 and we get 3, 4, and 3, which would be the numbers you would use in the empirical formula for vitamin C. So we would have answer choice B, which is C3H4O3, and that's the right answer. Okay, so moving on to our last 2 questions that we're going to go over today. We have number 4, which is how many grams of carbon nitrate can be produced by reacting excess HNO3 with 7.40 grams of CaOH2. So with this one, it's just a lot of reaction stoichiometry. So in the bottom, I have the actual reaction balanced out. So you have 2 HNO3 plus CaOH2 becomes CaNO3, 2 plus 2H2O. So we start out with the 7.4 grams that they gave us. We want to multiply that by 1 mole, and 1 mole is equal to 7. The molar mass, well, the molar mass is 74.078 grams per mole. So we're going to multiply that out and divide that. Then we have, because of the equation, it's 1-to-1 for moles. So we cancel out the number of moles of CaOH. And then we're going to have the number of moles of CaNO3 too. We're going to multiply that by the number of grams per mole again to cancel out the number of moles and get the number of grams, which was the answer we wanted, which is going to come out to be 16.3919 grams. Round that to 3 significant figures, it's going to be 16.4 grams, which is answer choice B, which is the correct answer. Okay, going on to number 5, which is the last one we'll be doing today, is what is the volume of 12 molar HCl? What volume of 12 molar HCl is required to prepare 16 liters of 0.250 molar HCl? So we know that molarity equals moles of solute per liters of solute. So with what we were given, we have 0.25 molarity equals an unknown amount of moles over 16 liters. So that amount of moles is going to come out to 4, which we know and we will use to find how many liters of 12 molar. So for 12 molar HCl, we have 4 moles, and for liters, it's going to be 4 divided by 12, so we're going to have 0.333 liters. And then we're going to multiply that by 1,000 to get how many milliliters, which is going to be 333, and that's answer choice B, which is the correct answer. So test 1 isn't going to be too difficult. It's just making sure you see the little things because they're going to try to trip you up. It's just going to be a lot of reaction stoichiometry, a lot of stuff on molarity, and going from moles to grams, grams to moles, and doing all those different reactions and different just calculations exactly right. So hope that helps a little. Thanks.